Well, hey everyone, and welcome to our physics homework tutorial.
We hope you find this tutorial helpful in your study of physics, and if you do, please visit our website at www.physicsvodcast.com.
There you're going to find over 200 physics examples in every topic of physics. It's sure to help you get through that physics homework. We'll see you then. Hello everyone, and welcome back to our next installment of centripetal force problems. Here we have a 45 kilogram monkey swinging from the end of a 2-meter vine. He begins at rest when the vine is at an angle of 30 degrees. Calculate the tension in the vine at the lowest point of the monkey's path. Well, this problem actually incorporates two separate things. First of all, we need to be able to figure out how fast the monkey is traveling at that lowest point. Once we know his velocity, then we can get into the centripetal force part of it. So to begin with, we need to use energy to figure out how fast he is traveling at the bottom. Now remember, with energy, the first thing you want to do is mark out the 2 points that you will be using. So our starting point up here, 30 degrees, will be 1. The bottom point will be 0.2. And you may recall from our unit on energy that when you're dealing with a circular path such as this, what we really need to know is how high the monkey is between his initial starting point and his lowest point in the path. The shortcut to finding that is to split this little triangle up into 2 pieces. Okay, so what we want to do, we have a right triangle here. The hypotenuse over here is the length of the vine, and that is 2 meters. The very top to the very bottom is also the length of the vine, and so that is also 2 meters. However, we can find this side as being part of that right triangle. So if our 30-degree angle is up here, we know that the cosine of the angle, 30 degrees in this case, is equal to the adjacent side. Now we're just going to label this as x. It's actually not a distance that we will be using in our calculations, but it's something we need to start with. So that side of the triangle x divided by the hypotenuse, which is 2 meters. And again, we have a 30-degree angle, so we can solve that for x. And we find that x is equal to 1.73 meters. Now, why is that useful? Well, if we know that this is 1.73 meters, and we know that the whole entire thing is 2 meters, then the difference between those should be the height that the monkey is initially located at. So the height then would just be taking the entire length of the vine, which is 2 meters, subtracting off that side, and we end up with a height of 0.27 meters as the monkey's starting point from the beginning of his path.
All right, now that we know how high up the monkey started, what we will use again is energy to calculate the velocity that the monkey has at its lowest point there. That's the key thing that we're looking for right now. So this is going back to just conservation of energy. So we know that at the beginning the monkey has some kinetic energy and some possible potential energy. We'll say KE1 and PE1. That will be at the starting point for the monkey. And that the kinetic energy and the potential energy that the monkey has at point 2, which is again at the lowest point of the path, that those must be equal to each other. All right. Now, as the monkey starts, we know that the monkey started at rest, so no kinetic energy to start with for the monkey, only has potential energy, which is, again, equal to the monkey's mass, which is 45 kilograms, okay, times gravity, 9.8, times the height that the monkey had off the ground, and that was that 0.27 meters, okay? Now that is equal to the kinetic energy plus the potential energy that the monkey has at the end, or at its lowest point, okay? Well, there's no potential energy at that point, it's only kinetic, and so that is going to be equal to 1/2 times the monkey's mass of 45 times that velocity that the monkey has squared, all right? And so now we have essentially a problem that we can solve for the velocity, and working that out, we will get that the monkey's velocity at that point is 2.3 meters per second.
Now that we have the velocity, now we're ready to get into the circular motion part of it. And again, remember, we want to start all of these problems with a free body diagram. The other thing that we might want to include here is a little sketch showing where we are on the circular path, and in this case, we are at the lowest point. Now, why is that an important fact? Well, that determines the direction of the centripetal force. Remember that centripetal force is always directed towards the center of the circle. So when I make this free body diagram, we need to have a centripetal force or a net force. Okay, so when we say centripetal force, we are really talking about the net force between all of the other forces acting on the object, and that centripetal force needs to be in the upwards direction. Now, what forces do we have individually? Well, we certainly have weight, and weight, of course, can be found by using mass times gravity. We also have the tension from the vine. That's our unknown. That is in the upwards direction. But notice that if our centripetal force is going to be pointing upwards, the tension must be larger than the weight. That allows us to have more force in the upwards direction. Again, you kind of want to think about this as saying, well, the tension is supporting the weight of the monkey, but it also needs to add a little bit more force there so that it can cause the monkey to travel in a circular path as well. So now we're ready to actually write out an equation showing this. And again, the easiest way to start is to say that the centripetal force, or the net force, is equal to the tension minus the weight. Now we can substitute in our smaller equations. Centripetal force is equal to mass times tangential velocity squared divided by radius. That's equal to tension minus our weight, which would be mass times gravity. Now again, we can start plugging in numbers that we know. The monkey has a mass of 45 kilograms. Earlier we calculated the velocity at that point as 2.3. The radius of the circle is the length of the vine, that's 2 meters. Our tension is our unknown, and weight can be found by taking his mass of 45 and multiplying it times 9.8 for gravity. And finally, we come up with an unknown value for tension of 570 newtons. That would be enough tension to both support the weight of the monkey and also supply the extra force needed to cause that monkey to travel in a circular path.